this second day session on computational thinking. So yeah, again, any questions from last session? So in case you have any sort of question from yesterday's session, please do let me know. Let me go over this screen. Okay. Where is the zoom? Here it is.
Actually, I cannot see your screen clearly.
Okay, you can't see my screen clearly. Let me just share this as well. Now you can probably see better.
Yes, it's fine now.
Okay. So guys, any questions from yesterday? Was there something you figured out that was not clear? Okay, no issues. So let's.
Hello.
Yep.
So I did check your YouTube channel and saw the videos which you recommended.
Yeah.
They were quite informative. Even I saw the doctor one. That
Okay.
was like very informative for me.
Awesome. You like it? Cool. Okay, and also I recommend joining the Facebook group as well. Today I'll share the Discord link as well. Okay, so using that you will get the constant update of what's happening right away. Okay, so suppose there are a lot of shows which are going to happen. A lot of future events are planned. So whenever an update is there, whenever an event is there, you guys will get the information about the event, and you can take benefit of that. Okay, so yeah, I'll share the links after the end of this session, so stay till the session ends. Okay, after that we'll talk about those links. All right, so let me just start presenting. Okay, all right.
So if I'm not wrong, is this the first session?
This is the second session.
All right.
Okay, if you missed the first session, you can find it on XRDI's YouTube channel. Invest 1 hour and you are good to go. Okay, so yeah, today we are going to talk about a very this is very close to my heart because this is very important. A lot of people miss this. Okay, so today we are going to talk about computational thinking, but first let me check if my YouTube streaming is working fine or not, because I have not checked that. Let me just begin in. Yeah, everything looks fine, and we shall begin. All right, so we are talking about computational thinking, and it's you guys might have heard about how computer works or not, but we are going to dive into that in today's session. After this session, you guys will get on the same level, whether you have taken the technical background. By technical background, I mean computer science as your subject or not. After this session, you will have the base level idea of what a high level idea of what the computational thinking, or how computer works, or how programming languages work, and all those. Okay, so for building virtual reality, augmented reality program, what you have to keep in mind, after that you will understand, okay, that what should be my thought process when I'm trying to target a computational thinking or a virtual reality project. Okay, so now let's see the first page. Now I have a poll for you guys. You can similarly, you can tell me that what do you see here. There, if you think it's a 123, type A. If you think this number is 1, 2 and 3, type B. Okay, so whatever you think, whatever you interpret this number, type accordingly. Okay, so give me your opinion, give me your poll, what you think it is, A or B. There are a lot of B's. Any A? There are A as well. A few A, but a lot of B's. So yeah. Amazing. So whoever is saying A, he is correct. Whoever is saying B, he is also correct, because there is no wrong answer. It's very, very simple. It's you know about it, right? It's 123 or 123. It's both the same thing. But why I'm asking you is 123, whoever is saying 123 is doing some sort of mathematics in their heads, okay? And we learned about this mathematics in our elementary education, and we know this mathematics so well that we don't have to do that every time when we see this number. We just know it's 123. So what sort of a mathematics we are doing in our head? We are doing this. We are making sure that this is the first number, which is, this is the first place, this is the 10th place, and this is the 100th place, okay? And then we are multiplying 1 to 100, 10 to 2, and this 3 to 1, okay? And then we are adding that, and then it becomes 123, like this. All right, so this is called decimal number system, and you are grown up with this decimal number system in your heads. That's how you are taught since the beginning of the education. This is why you saw the number 123 and you interpreted it as 123 without any problem. All right, so it's no rocket science, and you understand this decimal number system. You can also say this decimal number system is so old with humans, so old with our humanity, that it's almost intuitive for anyone to calculate. You understand this very easy. But there are other number systems as well. For example, there are in Roman number system is a different kind of number system, and there are plenty other number systems as well, like hexadecimal and all, where the base, can say 10. What is base? Does anyone know about base? So base is basically the base number, and these are the powers. So let me tell you about that first. So here the base is going to be for this decimal number system, the base is always 10, okay? And when you keep the power 0, 10 to the power 0 is going to be 1. Now what is going to be 10 to the power 1 is 10. 10 to the power 2 is going to be 100. 10 to the power 3 is going to be 1000, and so on. So any number system has a base. Suppose that how many numbers individually it consists, okay? That number is basically the base. Base is nothing fancy. How many characters are in there in the number system? For example, we have 0 to 9. That makes it a base 10 number system. 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So total are 10. Okay, so 10 is the base of our number system, and that's how it's called as decimal number system. And whatever the base is of that number system, it's used, and it's that is the most important, and that's how we think about when we talk about this number system. But there are other base number system as well, like hexadecimal, which is the base 16 number system, and so on. Okay, so now we are mostly interested in this session is the binary number system, which is a base 2 number system. Okay, remember what we did here: 10 to the power 0, 10 to the power 1, 10 to the power 2, 10 to the power 3. Similarly, in the decimal number system, what will happen? This will happen: 2 to the power 0, which is again 1, 2 to the power 1, which is 2, 2 to the power 2, which is 4, 2 to the power 3, which is 8, and so on. So that's how it becomes the decimal number system. So when we are talking about decimal number system, we have to care about 2 to the power 2 to the powers. Yeah, 2 is our base number. Okay, it's not mathematics. It's it's supposed to be very easy. Okay, so now just listen. Okay, so now either whatever the number system is there. For example, if I make it 0 here, what will happen? 1 times 0, okay, that becomes 0, or 1 times 3, that becomes 3, or something like that. Similar happens to this as well. Okay? But here there's nothing different than on and off, okay? Because there are two possibilities only, 0 or 1, on or off. So now let's calculate. Now let's try to understand what is this number. So that's the second power, and when we try when that is on, what it becomes, that it's not 1. Okay, so 1 0, what it becomes, it becomes 0. Okay, now what is adding? 2 to the power 1 is 2. Okay, So 1 and 0 is what it became, 2. Okay, plus 4, what it became, 4 plus 2 plus 0 means 6. So what it's written 6. It's very similar to what we did here, exactly similar to what we did here, but this is number 6, not 110. Okay, so when we are talking in binary number system, there are two possibilities only, 0 or 1. This is why it's a base 2 number system, and rest of the calculation is very same as the decimal number system. There's no difference in that. All right, you got my point? Any confusion in there? Okay, now I'm going to ask you that how you are going to, now in chat I want the answer, how you are going to write the number 15 in in binary number system. Okay, so let's see chat. This is correct, this is not correct. Yeah, perfect. Awesome, awesome. So you got the idea that how decimal number system works. Okay, so now let's talk
Oh,
about,
actually, I didn't understood this.
okay, no issues, no issues. Let me go over the calculator or notepad or something like that. Hold on. Let me go over notepad. Okay, so suppose let me make the text bigger so that you can see. Okay, suppose I have to calculate 15 or whatever the number, suppose 27. Okay, now what we'll do, if I have to convert this 27 in binary, okay, so I have to basically think that what is the closest number which is going to be near to 27, and how many bit we require to create 27. Okay, so suppose 2 to the power 0 is going to be let's write down the base of that number. That will make it easy. So first is 0, of course. Okay, 0 or 1 ka base. Okay, 2, hold on, let me make it easy for you. I can also write this. This is 2 to the power 0. Okay, this is, yes sir, आपको 2 का ही power है. Okay, like this. This is 2 to the power 0, which is 1. Okay, after that what's going to be here, it's going to be 2 to the power 1, it's going to be 2 to the power 2. Notepad is not a very good tool. 2 to the power 3, 2 to the power 4. Okay, and when we'll write down in between what is going to be 2 to the power, what is it, 1. 2 to the power 2 is going to be 4. Okay, 2 to the power 3 is going to be 8. 2 to the power is going to be 16. Okay, so we got this. Okay, we got this. Okay, so now the question is that what number you have to replicate this number. If you have to replicate this number, you have to somehow create this number from these numbers. Okay, now let's take one more input. Let's add 5 as well. So 5 is going one, we are adding one more bit, and the fifth is going to be 16. All right, so yeah. Let's go here. Spacing problem. Notepad is not a good tool. Okay, amazing. So this is the scenario. Now I have to create this number. Now again, if I turn on this number, if I turn on, suppose the bit of this 32 bit, then it's exceeding 27, means it should be 0. It should not be 1. This bit should be 0, which I definitely know. Okay, does 16 has to be on or not? Obviously, because without 16 you cannot replicate this number, so it has to be 16. Okay, now this bit has to be on or not. Let's see. So does 16 plus 8, how much it is? It's going to be 24. So of course this is also smaller, then we'll take this bit on as well. Okay, Now what number we are representing here? If suppose rest the bit are off, like this, okay, rest all the numbers are off, then what number are we representing right now? It's 24. How we are representing 24? Because this bit is on, which is representing 16 plus 8, it's 24 right now. But we don't want 24. What we want is 27. How do we add 27? Suppose if we add this fourth bit, if we turn on this bit, what it will become? What this number will become? 24 plus 4, 28. But we don't want 28. What we want? We want 27, which means this bit has to be off, and it will again become 24. Okay, so let's try turning on this one. Now what number become? This number plus 2, which means it became 26. Okay, now turn on one more bit, this one. Now what number it became? Now it exactly became 27. So we wanted 27 and we get 27, which means we converted into binary. All right, so this is a small mathematical overview of how to get your number converted. So I'm sort of going to paste this number in the Zoom link so that you know is 011011 is 27. All right, is it clear now? So this similar thing happens in the decimal number system. Is the very same calculation happens in the decimal number system, but you are so okay and so natural with this calculation that you don't even care. Here I change only the base and you need to ask it again or something, because you are not very familiar with this language, with this binary number system. Okay, now my question is, if we are not very good with this language, then why do we use it? Okay, then why do we use binary? And the answer is that why do we use binary is that it's very easy to maintain. It's very easy to maintain two states. Two states is not a movie. Two states of a semiconductor or something like that. Okay, so it's very easy to maintain just two states, and it's very hard to maintain 9 states. Okay, how do you maintain 9 or 6 states? Have you seen a fan? Everybody has a fan in their ceiling fan in their home. There is a regulator.
Yes.
There is a regulator which controls the speed of the fan, and that regulator usually has 6 numbers in it. Okay, when you are controlling with that regulator has a base 6. That regulator has 6 states to control. Okay, but in physical form it's very hard to create multiple states and reducing the size. Has anyone seen a semiconductor? They are very, very small. They are very, very tiny. Okay, so when you have to create those, you have to go really, you have to make sure that you are maintaining very, very small states. Okay, so this is why we choose either on or off. It's very easy to maintain these two states, yes or not, magnetic or non-magnetic. Okay, so this is just 2 states, and we can represent these 2 states in any form, right? This is why computers choose this binary language instead of natural human language. Okay, because with human languages we cannot maintain multiple states, and it becomes very complex, and we cannot scale it very much. Okay? Because you cannot reduce the size. Then in a processor you cannot fit a billion transistors. Okay, so for a transistor to be smaller and smaller, it's very necessary that it keeps the smallest amount of state possible. Okay, and the future is going to be the quantum computer, obviously, in which every single qubit is going to be either off, either on, or both at the same time. Okay, but that is not the part of this subject. We are just dealing with, this is called traditional traditional bits and bytes. So that's how computer communicate with each other. That is the only thing computer understand. Computer does not understand anything else than these ones and zeros. Now you will argue with me that if computer only understand these ones and zeros, how does computer understand languages, how does you are able to send text and all those things. Okay, so what humans did, humans came up with a map, and this is this map. This map is known as ASCII. Okay, American Standard Code of Information Interchange. Okay, something like that.
So this looks like the Morse code.
This is not the Morse code. Morse code is different. Okay. However, they both are maps. Okay, it's like Google Map and Yahoo Map or Apple Map or something like that. They both are map. They both are representing the conversion between the numbers and the alphabets. Morse code and this binary code. They both are almost. They both are doing the same thing but different ways. Okay, one map the location of that number is different, and on the other map the location of the map number is going to be different, but a map is a map. Okay, map, what does map do? Map converts something meaningful into something random. So this 65 number is very random. There's no sense why it's 65, but it is 65. Okay, so and this map has to be followed by whole over world. All right, only then one person could be communicate to other person. Okay, so now humans decided that we will create a map of our languages. Okay, whatever the alphabets we have, A, B, C, D, E, F, G, and whatever, we are going to create a map for that. How we'll create that? We'll assign a number to 65, for example, to A, and so on. Okay, similarly till Z. So we'll assign a number and we'll map that A to 65. Whenever you'll say A, I'll respond 65. Okay, because to me, I don't understand alphabets. Computers cannot understand alphabets, but they can understand numbers, and they cannot even understand numbers. They understand only binary. So then this second map is converted back to this binary code. If you calculate, reconvert it back to number, it will become 65. So this 65 is converted to this number, this 66 is converted to this number, and so on. So this map you are looking at right now is the map for the alphabet. So suppose whenever you are sending someone a hi, you are sending these numbers literally. Okay, 72, 73, and 33. So according to the ASCII code, H is 72, I is 73, and this exclamation mark is going to be 33. Okay, so first we follow the ASCII map, and then the ASCII map is again converted back to binary. So what H is going to be? H is going to be this number 72. Then 72 is going to be converted into the binary form of 72. Only then your device can understand that it's H or is this message. So that's how information is going to be exchanged from a binary perspective to a natural human language, which is English. So now you will argue, okay, this is English, but there are so many other languages and there are so many other symbols and all that. Okay, so now the solution is, now the solution to this is, we are going to have a lot of numbers, we are going to have a lot of maps. So for each language, like this is ASCII, American Standard Code of Information Exchange, there are other maps as well. Got it? For example, you have all sort of things, and even these sort of smileys. For smileys, you have other different kind of maps. Okay, like this number, this poop symbol has this number, this big number, not 65, this 100,000 number something. Okay, this number, when you type this number, convert this into binary and send it to someone, it will become this symbol. Okay, so whenever you are sending a message, a smiley to someone, you are sending this number literally in binary. Okay, so that's how the map is followed. Now a fun fact, why this smiley is yellow? Okay, let's think about it. Why they choose yellow? They could have chosen any other color, but why yellow? And answer is RGB values. Okay, RGB and HSV, they are two forms of expressing color information in binary. Okay, so now we are going to take a look at that. This number, this color of this smiley is created from these numbers 72, 73 and 33. And as you also remember, this is the same message. Okay, so when you send someone, it's 72, 73 and 33. And now this smiley which has the same color, okay, now it's also representing the hi message, but in a different format. It's a creative decision to choose this color. Okay. Now we are going to talk about how with three numbers we can represent any color. So with three numbers, red, green and blue, these are also called as channels: red channel, green channel and blue channel. And based on this information, with just these three numbers converted into again binary, you can represent color. Okay, any color. Since you can represent any color, you can represent values based on what values you are trying to send. For example, if you are, this is a single channel image, like I said, this is a 3-channel image, which means a color image. But there can also be a single channel image, which means a binary image, which this is literally called a binary image. Okay, it's a single channel image. Okay, so now take a look at that. This number is 157, which is a very in mid-range number. Okay, if the value is very low, it produces a very dark color like this pixel. Okay, this is just 5 and this is the blackest pixel, one of the blackest pixel. This is just 9 and this is also black, but these numbers are higher. This is 237, this is 252. Okay, and if you can imagine, this is a very low resolution picture, but it's Abraham Lincoln. Okay, so whatever the image you want to express, you can arrange these numbers in such a way that it takes shape of a picture or something. Okay, so whatever you want to represent, it's somehow converted to these numbers, and that these numbers get converted into binary, exactly same binary. Suppose this is 1, so it's going to be converted the 1 to the binary. Okay, this is 1 and 0, then it's going to be converted to 1 and 0 binary, and then it's going to be sent over network or over your friend's message or something. Okay, so if you are sending a message, you are sending this much information converted into binary, and this is a very small information because this is a low resolution image and this is a very single channel image. Usually there are 4 channel in a in any image, and there are much more pixels. Speaking of which, we can for example, this background image, for example this image, okay? This image has 1920 pixels in this way, from this direction, which is a horizontal direction, okay? And 1080 pixel in this direction, okay? Vertical direction. So multiply that, so this many pixels, okay? 1920 times 1080 pixels are going to be sent again going to be converted into binary, and then going to be converted into these value, then binary, then going to be sent to you, and then recreation from binary data to this image is being done on your machines. This is why you can see this screen right now. All right, so now let's talk about what is a video. Okay, we saw video, we watch video each day, but we never thought that what is a video. Now let's think about it. Here we are seeing a video, but this is world's first video. Okay? It's 1878. A photographer clicked pictures, and as you can see in the bottom, there are 16 pictures only. All right, there are 16 pictures only, and the pictures are being repeated in 1 second. 16 pictures are being repeated, so it's a 16 fps video, which means a video is nothing but just a collection of pictures. Okay, so these are some 12 pictures out of those 16 which are being played rapidly. And in this video there was no video, there was just these pictures repeating one by one, just these pictures, just these images, but they are being repeated so fast that your brain thinks it's a video. Has anyone ever seen a flip book? Has you guys ever seen a flip book?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So what happened in a flip book? Let me show you a flip book Avengers. So in this flip book, there's no such thing as a moving image. Okay? This guy is going to sketch each and every scene of the Avenger movie. Okay, I'm always angry scene. Okay, and he is going to do that one by one frame. There's no moving image at all. But when he plays that, see what happens. It became a video. Even a physical picture, which you definitely know not moving, becomes a video. So if still images are played very fast, if any still image is going to change itself in sequence and in very fast, okay, it becomes a video. It appears as a video at least. Okay, so what is the threshold of being a video and not being a video, if you ask me? So I'm going to tell you the threshold of a video and not a video is 12. So if you are looking at less than 12 frames a second, it doesn't appear your brain as a video. It will appear your brain maybe as a stop motion or something. Does anyone know about stop motion? So there is
Yes, sir.
something called
Yes, sir,
stop
yes, sir.
motion.
Yes,
Yeah,
sir. Yes,
yeah,
sir, we know.
yeah. It may
So
appear
in
as
that video which you showed within that flip book wherein they drew each and every scene and they played it in a sequential form, that was an example of stop motion.
Yep, totally. Okay, so we are talking about here, yeah, if it's less than 12 fps, it might not appear as a video, but above than that, it appears as a video. So usually, what is the number and where this number goes? So normal video on YouTube, what you watch is 30 fps, and you also in some videos have option to rescale to 60 fps. Okay, a normal game which you play in virtual reality is somewhere between 70 to 90 fps. Okay, and the screen refresh rate of a gaming laptop like one of I'm using is usually from 90 to 144 fps, and it could go, I think, higher as well, to maximum to 256 fps. But there's no much sense of using that high laptop, because the software, the images from the software are not going to be updated that fast. You doesn't need to update, because after 60 fps it's almost the same. Okay, you got the idea. Now let's talk about, now you know what are images, now you know what are videos. Let's talk about what are languages and what is algorithm. How do you, if you are not from a coding background or programming background, how you should see coding or programming? What is the essence? What is the one word for coding what I could give? And that is a black box. So after 8 years of experience, 8 years, no, 12 years actually, I'm coding for past 12 years. So after 12 years of experience of writing codes, I could say programming languages are like a black box. Okay? There is always a function, and function is basically a map, like similar map you saw here. Okay, a map. So like this map was converting from A to 65 or Q to 81. This coding map, whatever it is, it's called algorithm, and this map is converting or mapping between input and output. So on one end you have some input could be anything, okay, and on other hand you have to get some output. So whatever the input you will send, based on that input the algorithm will take some steps, okay, do some operations and cook your output in such a way that its ingredients are the input. Okay, so from the ingredients of input and output is cooked. That's the essence of any programming languages. So you have to make sure, obviously, a certain things, that you make sure that you provide input in a very limited way. They are not the programs takes input in a very limited way. There's mostly only one way to give input. For example, if you write a program which is expecting your age and you send the alphabet 24 or something like TWENT by 20 and 4, okay, then the program is not going to understand that, because the format of the input is not matching with the expectation of that algorithm. Okay, then the program will break. So what programmers do? Programmers basically make sure, sometimes they give tips that don't enter languages, enter only numerical value, something like that, which you might have seen in forms and all that. They restrict you either, or bad programs actually go break. Okay, so but we are going to write some good programs here. Now I'm going to talk about 3D. Okay? So there is, first let me tell you, like you already saw, there is no such thing as videos. Okay, because videos are nothing but these still images moving. There's no such thing as images, because images are nothing but these numbers, and based on this number a color value is generated, and when you look at those color values it looks like an image, but there are just numbers and intensities. All right, then again, there are no such thing as smileys. Smileys are again number. There's no such thing as alphabets. There's no such thing as this hi message. Ultimately it's binary. Similarly, there's no such thing as 3D. Ultimately it's values. Okay, and these values are literally affecting the very essence of a 3D model or object or anything. Okay? So a single point in any 3D model, for example, one of the simplest shapes which you can create in 3D software is a cube. And how that cube is created? So we assume a world of boundaries, boundaryless world, okay, and we called it a Cartesian coordinate system. On that coordinate system there is somewhere a center, and we call that center as a 0 0 0 or origin. Based on that particular origin we start pointing some points. Okay, for example, and this Cartesian coordinate system obviously is going to have some units. Okay, for example, 1 is not just 1. We assume that 1 is going to be 1 centimeter or 1 meter. These are going to be the units of measurement. Okay, measure unit of distances. So for example, if I plot the first point at center, which is 0 0 0, at the very origin of my world Cartesian coordinate system, okay, this first point, where is it going to be? In x direction it's going to be 1 unit far. This 1 could be anything, 1 centimeter far, 1 inch far, or 1 meter far. You, based on other softwares, you get options to select this unit, the intensity of this unit, what you want to choose, either inch or centimeter or meter. For example, Unity takes meter. Okay, so if 100 is the number which is written for the value 1, it's going to be considered as 1 meter in the x direction, positive x direction, because there is a negative x direction as well. All right, where is the negative x direction? Just in the opposite way of positive x. So for example, right hand is the positive x, so left hand is going to be the negative x. Similarly, y is going to represent the up, and z is going to represent the further ahead or further back. Okay, then we point all these virtual points, because these points does not exist. We are just imagine right now we have the real-time rendering engines, which means whatever the value you put in, and most of the time you don't even have to put any value at all. You just see the model at runtime. But in the earlier stage of rendering engines, you have to put all these values by your hand and create these models, create those calculation in your head, that what is the outcome of this particular point in at that particular number. So you have to imagine at what space it will take, and the rendering of that particular point is going to come out after a week, because there were rendering farms which used to do those rendering calculations and create model eventually. Okay, so these values are still very relevant, because in your career somehow and somewhere you are going to land upon these values. You have to trick these values some ways. I'll tell you in what condition you have to. So these, based on these values, you imagine that okay, in left is going to be 1 point, right is going to be 1 point, 1 point going to be in the upside, and you put all those values in these conditions. Then the rendering pipeline starts. Okay, so first you plot the vertex. The single point is called as vertex, and the collection of point is called as vertices. All right. So you whatever the you feed these vertices into an algorithm which is called rendering engine. The first thing rendering engine does is plot all these points. Okay, like you imagined in your head that somewhere are going to be a 0 0 0 and somewhere is going to be a 1 meter in the right of 0 0 0, which means 1 0 0 0. The same calculation this vertex processor does and plot these points. This line is imaginary. This line is not actually represented because there is no way to render this line. Okay, so it plots all the points. Then comes the second phase of rasterizer. So rasterizer will do nothing but decide how many pixels will be affected by this shape. Okay, so whatever the shape is going to be created of these hollow points, how many pixel it will affect. Usually it doesn't look very much, but the screen on which you are looking at is divided into very small grids. Okay, those grids are called as pixels. Based on these pixels value, either this particular triangle will occupy the pixel or not occupy the pixel. Okay, so this rasterizer do that test that either the pixel is occupied by this shape or not, and it creates a map like this, either it's occupied or not. Then there's a fragment processor, and fragment processor is going to do a lot of calculation. Now we know how many pixels are getting affected because of these shape. Okay, now we know. So fragment processor, this buddy is going to do is going to decide the color of each pixel. Okay, so it's going to iterate over all these pixels, all these selected pixels, and it's going to talk about, hey dude, what's your color? Hey dude, I'm going to tell you your color. Okay, so this is the job of this fragment processor. And what are the variables which it take in consideration of deciding a color? It takes first the texture, which is also known as UV, then texture. Okay, UV is a map that how the texture is going to be applied on an object, and texture is the texture is a normal photo. You can say texture is an image. I'm not going to go in detail, but yeah, sure.
So is this algorithm going into the fragment processor?
Yeah, I'm going to do that. So fragment processor is a dude which tells each pixel. So first rasterizer decide, are you in the shape or not? Okay, then fragment decide what is going to be your color for a pixel. Okay?
Yes.
Rasterizer decides, is the pixel is in the shape or not? Fragment decide, okay, this pixel is in the shape, but what is going to be its color? And based on what it decides the color, it takes various things in mind before deciding the color. Is it going to be affected by the lighting or not? Okay, and if it's going to be affected by lighting, how much it's going to be affected by the lighting? For example, if the pixel is in non-light area, it's going to render as black because there's no light, there's no reflectivity. Okay, so similarly, fragment processor is also known as a shader. If you have heard of, this fragment in a shader there are two parts. One is the vertex shader and the fragment shader, or fragment shader also known as surface shader or something. So that is particular section of code which basically calculates the color of a single pixel. Finally, when this thing is calculated, now a 2D image is being generated, and that 2D image, 2D array of values. What is our image? Array of values. Like we show you the Abraham Lincoln picture, it's just an array of values. Okay, array means two-dimensional grid. Okay, got it? So it's
Yes,
a 2D array, means two-dimensional grid of values, which is being sent to CRT monitor or whatever the kind of monitor you have, and then this monitor's job is to render the image as it is. All right. So
Yes,
this
sir.
is the whole process of how the graphic rendering is work in theory, right? Again, I'm going to repeat that again. The vertex processor is going to be there. Vertex processor is going to do this. There are not going to be any lines, but just placing the dot based on the positions. The primitive processing is also going to be there, which creates the lines. Okay? The printing processor is going to take a lot of things. For example, aliasing is one of them. So we are not going to talk about that in this one. But then comes the rasterization. Rasterization is basically going to tell you that it's occupied by is this pixel is going to take shape or not. Is this pixel belongs to this shape or not? That's it. Okay. If yes, then fragment processor is going to color that pixel, and then finally that all the information is going to be sent to frame buffer in form of texture. Okay. Now, again, as you already know, this process is very hard, and putting values, each and every values by your head, that where this pixel is going to be left or right, where this edge is going to be in left or right, front or back. Okay, it's very hard. So we have some helper tools to put this pixel on those position, to put particular points, these points which are called vertices, on those places. And what are these tools? Popular tools are 3D Max, Maya, Blender. All these are artistic tools. So if you have some artistic knowledge, again, it takes a lot of knowledge to work on these tools as well. So if you have some sort of artistic knowledge or creativity, these tools will let you help to put those each and every individual pixel, okay? Each and every individual vertex. So you put those vertex, and these tools render the object, and finally you can export the object and make the object more alive using rendering engines like Unity, Unreal, Buildbox, and so on. Okay, so you export the objects in form of files like obj files, fpx files, and there are many format. Okay, and these Unity and Unreal, their job is to make the character alive, make the shapes alive. So they don't treat the shape as a series of pixels or series of vertex. They deal the shape as a singular point, okay, which is also known as rigid body. Okay, whatever the rendering and physics they apply, so they are rendering engines and physics engine, they both have. Okay, so whatever the calculation they'll apply, they'll take a center position, or whatever the position you want to take, you also specify in this section, which is known as pivot. So whatever the pivot you define, these engines are going to take the whole shape as that particular one point, and you play on that particular one point, or in this tools. Okay, in these tools you can do mainly three things. Okay, not that much what you can do here, because these are here you have control of each individual vertex. Okay, if you want to make the nose bigger, you can make. All right, if you want to make it deform, you can definitely do. But here you don't have that control. Here you have a different sort of control, and that control can be also considered as three things, mainly four actually, but most of the engines don't support the fourth. So what are those three properties? Transform, scale, and rotate. So you either make transform, either make scale, or either make rotate, and make these shapes more alive in these rendering and physics engines. They help you with the physics, that how the cubes should behave when it's falling, okay, and based on that you do all the calculations. Now you may ask or argue that what is a depth? If no such thing is 3D, why it looks 3D? Okay, so the answer is, in virtual reality, why things look 3D is this image. Again, this image is, I think, 1806. It's a very old image. So this is one of the first stereoscope. Okay, what is a stereoscope? Monoscope is going to be a single vision object, but this is a stereoscope. What does it actually mean? Which means these two images which are in the background, they may look exactly same, but they are not same. These images are taken and offset apart, which is known as IPD, interpupillary distance. Okay, so based on that IPD, these two images are captured. So this is from your left eye distance and this is from your right eye distance, and these images are captured. Then you have to re-look in this sort of device, in which when you look at the left image will go in the left eye, the right image will go in the right eye, and when you compare and when you look through that, you'll notice that now it looks more 3D. You assume depth, and based on the same concept, all these devices are made, even the recent one. All right, so today's virtual reality is based on this stereoscopic vision. So let's talk about, this is Sensorama. This is Sensorama was a very cool, it was built by a Hollywood director, and in this there was a program, there was a video, there was a movie on which you were riding your motorcycle on a bridge. Okay, and when you were doing that, you can feel the vibration of the motorcycle. You can also feel the air on your face, okay, the moisture of the air and all those. You can feel the fragrances. You can look inside, and it gives you an experience of being there on the motorcycle. Okay, so this is Sensorama. Then these sort of technologies, I think this is named as Cockpit 1. Okay, so Cockpit 1 was for Air Force training. So they used to train their pilots on these sort of simulators. As you can already see, this is too heavy. This is Sega's VR, which never released because it was very unpractical to release that. However, this is Virtual Boy from Nintendo, which was released, but it did a great success because it was too early and the technology was not mature at all. But in 2015, two companies, Oculus and Vive, take the opportunity and build these systems on which you can definitely say them a modern age virtual reality system, and still the technology is pretty much same. Okay, now we are going to talk about, I think this is pretty much it for this session. So let me how much time? Okay, we are time. Okay, so this is pretty much it for the session, and I'm going to now introduce you and give you the link to our Discord channel. Okay, so these are all the links which you may require, and this is a very important link. This is the link to our Discord server. Okay, I'm going to send the link in the Zoom meeting itself. In the chats, I'm going to drop the link for you to join. This server is for all the needs you might have. Okay, let me also showcase you this server. So when you tap on this link, you can install the Discord app, or you can do it without as well. So you will reach at this destination. Okay, this is our Discord channel. In this, there is a journal where if you want to talk something, you can definitely speak up. And if you have any, you first introduce yourself here. Okay, talk about yourself and what you do, where are you from. Here are all the XRDI related links, which means you can watch our YouTube, You can go to our Facebook community, you can check our page, you can go to our LinkedIn, you can again Discord, this is our WhatsApp group, this is our website. Okay, so all the links which you may want are here. Okay, these are my personal link. If you want to communicate with me on Facebook, Instagram, LinkedIn ID, everything is there. You can have a conversation anytime you want. These are some educational links. There are a lot. Okay, remember yesterday I showed you that how to basically begin with yeah, yesterday I showed you a lot of details, but I also showed you the course. I said that it's a 3-year worth of course. So here are those courses. These links are those courses. If you tap on any of these links, you will basically, you came here. These are all the topics which are relevant to Unity, and you have to basically search about these topics. So for example, I go here, and what is behavior components in Unity? If I suppose search about this behavior components Unity, you get all the information you require about this particular subject. Okay, so these are very helpful, and this will guide you to train fast in Unity. And there are a lot of helper links as well, like start guide with VR start guide. In this there are plenty of other videos which you can follow. Yeah, as you can see, there are videos related to STC Vive, Oculus Go, Cardboard, everything is there. Okay, whichever you want to follow, go follow that. There are how to start with how to install Unity is there, obviously, and this is going to be your task. There is a AR Foundation link, that how you are going to start with AR Foundation. This is me talking about that, and in this video you in 3 minutes you can build your first app in AR Foundation with this video. But rest I talk about the details of building a more complex app in this application. Okay, building the better way. Okay, now you are going to need this link anyhow, because here we go. You have to, for our next projects, for our next day, you have to install Unity. So as you can see, the first link is there, install Unity. So if you tap on that, follow this procedure, whatever the procedure is being shown here. All right, wait, yeah. All right, so follow this procedure, search for Unity, download Unity, everything is there, whatever you need, and you will be able to, finally you will be able to install Unity. Got it? So this will be your final outcome. You will get this sort of editor. So you have to install Unity for next day session. So this link will help you, which is in the Discord link which I have sent you, and there is the educational links which you can follow. There are plenty of details, plenty of links. For example, if you want to know about GeoGlass, there is one more link which you can check. So definitely go and check all those links. All right, now also let me show you our website if you are not aware of. So this is our website, xrdi.in, and as I already said, we are working on this initiative of XR democratization, and there are plenty of details. There are plenty of events which we did in past. Okay, so yeah, this is XR podcast, my show which I host basically. Okay,
Excuse me, sir.
yeah,
Can you share the link of Discord?
haven't I?
No, sir.
It's in chat, isn't it? I've shared, I think.
No, it is not. I think this to a particular person thing it is went off. You have to change to everyone until.
It's not everyone, right? Oh yes. Oh, okay. Sorry, it's my bad. Okay.
It's okay.
So I'm going to send Discord link, and that is important because you have to install the Unity using that lead. So this is, again, now it's sent to everyone. You guys got it? Yeah. Come on this Discord channel, and we can basically discuss further. And these are the guests of our podcast. A lot of guests you can see. You can check, a lot of speakers are there. Okay? All these people are industry experts, and they came to support you, to teach you about how the industry works. As already somebody shared that he saw the lecture of Dr. Shafi Ahmed and his story. So there are plenty of speakers you can discover. I think we did 42 episodes of XR podcast, so it's a hit. Okay? These are some of our partners, event partners, technology partners, and education partners, in which a lot of colleges are there, including IIT Kharagpur. Okay, so yeah, you can definitely write about us or contact us using this link. On all the information is there on the Discord channel. Whatever you want, there are plenty of links, and I'll share this PDF as well. Okay.
So I have a doubt.
Yep, sure.
So when you pick a character, suppose let us pick the cube,
Hmm.
and when we make it wide, is rendering pipeline going to take place again?
Yeah, in fact, rendering pipeline is taking place in 1 second. It's taking place 60 times at least. Okay, so for example, whenever you can, by this definition, you cannot even see the scale. If, for example, you're scaling, and you will not be able to even see the object being scaled if the rendering is not being done again. Okay, because there's no such thing as object. uh, when you scale something, what happens is basically one of these numbers is going to be stretched apart. Like these values are going to be stretched apart. For example, this is from 1, it's going to be begin, it's going to be 4 or something. Okay, so if you scale 4 times, it's going to be 4, and the relative vertex is also going to be 4. And then it has to do re-rendering, and then it will generate a new image. In fact, rendering engines generate images 60-70 times a second, and that is the only way to see things moving. You see in your game things moving because the rendering pipeline is happening 60 times a second. All right,
Yes.
and that's what you call a frame rate. Okay, so without the rendering update, there's nothing which is happening on your screens. Okay, so yeah, join this Discord channel, and I can see a lot of people are joining, I think. Yeah, I can see people joining. That's good. You guys can join the Discord and check all the links. Make sure you check the links in which are mentioned in XRDI links. For example, this channel, there are education links in which currently relevant video is this one, the first one. Okay, these you can explore later based on your curiosity level, but you have to check this channel where you make sure you subscribe each, no matter you interact right away or not. Because what will happen when you will stuck somewhere, or when you will see a video coming every week or something about XR, then you are going to build up your, then that's going to build up your knowledge about the XR over the period of time. So whatever the knowledge I have gathered it over the period of 7-8 years. Okay, similarly it will take time, but I am just here to be a catalyst in that process, make the learning process faster and so on. All right, so yeah, that's our job. And if you have any questions, this is the time for Q&A. If you guys have any questions, please shoot it.
So, sir, a quick question, like it's more regarding to technicality inside Unity.
Your point is regarding
The bloom effect, how can we actually get a bloom effect inside Unity without using universal render pipeline?
how can you get the bloom
Effect inside
the
Unity.
bloom effect inside Unity without using universal render pipeline. Okay.
Yeah, that was the question.
Yeah. So for example, there are plenty of ways to fake it. There are shader effects, like fog effect is there. Inside that, there are ways to render that bloom effect differently. But I think using URP is the easiest way. This is why it's here at the first place, because that is the easiest way. Other than that, all the other ways are basic, some sort of hacks. There are an emission component in the shader. So if you check the standard
Yes.
shader, there are emission component, and there are plenty of other shaders which make the emission even more powerful, which becomes almost like bloom. But the bloom which you use in URP is a post-processing effect, which means it also checks that where is the bloom, and it also renders neighboring pixels in that way. If you're not speaking, please make sure your mic is off. Okay. Yeah. Okay, hope you got it.
Yes,
We
sir.
few people are telling that they cannot get your website.
Not able
Can
to
you
get,
share that link also in the chat? Yeah,
not able to get my website. Okay,
share the link of the chat.
let me
Exactly.
here send it. Chat. Here you will find xrdi.in www. That should work. Okay, a lot of people are saying that they got it now. Okay, that is not much relevant, but Facebook group is more active, WhatsApp group is active. So if you connect into those two, you are closer to me, and you can basically communicate whenever you want or ask anything whenever you want. So any other questions? If we can take as much as possible, I'm just trying that. Any other question, guys? Any question in the comments section? Please share this recorded file. Recorded file is on the YouTube channel, so you can definitely check that out. Does ARF supports SDRP in Unity? I'm not a very good person to answer this, because I usually work with URP pipelines and SDRP as well, and most of the time without any of these two, because I have to, the kind of work I do, I have to write a lot of compute shaders, and when you are writing compute shader, that mean you does not need these custom pipelines or something like that. Okay? Which my job is a little different.
Sir, can we use Unreal for
Voice got cut off. Can I use Unreal for the?
the VR?
Yeah, definitely. Yeah. Unreal can be used there for VR, and Unreal can also be used for mobile game development and web development as well. Web development by mean I WebGL. So all the options are almost similar in both the platforms, but Unity is a lot more beginner friendly than Unreal. With Unreal, you have to a lot of struggle to get started. Or
So
like
can I use Unreal Engine tomorrow?
Uh, in the course we are covering Unity for everyone, but we'll definitely do a session with Unreal, but that is going to be only 1 or 2 sessions, because a lot of reasons.
Yes, exactly. Yeah, we are planning to put that Unreal session separately. We
Yeah,
don't want to overwrite on this session because this session is about extended reality using Unity Game Engine.
yeah,
Yeah,
that's correct. We'll do a session sometime else with Unreal. Definitely we'll
definitely.
do.
I'm happy to do. We have to do. We are happy to get that from you, Bobby.
Yep.
Thank you.
Uh, so, any other questions, students? Avi, first of all, I just want to thank you for today's session, and it was very. I think those who were don't know about even programming knowledge, and I think today they found it very easy way to get it know about that and with learning, and many basic things has been. I think they got it idea about that, and you took about a basic introduction of VR glasses and everything, and today the topic was very nice, and hoping for more coming days also in a better way.
Thank you, Ajay, and thanks for introducing us to these many people, and thanks to everyone for being here for so long and having the patience. And yeah, definitely we'll see you tomorrow, and have
Thank
a
you.
great time, guys. Thank you.
Thank you, guys.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you.
Thanks.
Okay, so this was today's session, and it's over. So yeah, see you tomorrow. Have a great time, guys.